create a table of values for all of the following equations, then determine the rate of change for each equation. So for the first equation, y equals x plus 3, I'm going to choose a number of value of x's. I'll start with 0, and then I'll try a few positive x's, and I'll try some negative x's as well. So if x is 0, y equals 0 plus 3, which is 3. If x equals 1, then y is 1 plus 3, which is 4. If x is 2, y would be 5, and if x is 3, y would be 6. If x is negative 1, then y is negative 1 plus 3, which is 2. And if x is negative 2, then y is negative 2 plus 3, which is 1. Now, to determine the rate of change, we want to know how much the y's change per x. Well, we can see that these y values are increasing by 1 as the x values increase by 1. So, the rate of change would be 1y per 1x, or simply 1. Why don't you take a look at number 3, pause the video after you make a table and you determine the rate of change. So, when you made your table, I hope you chose some both positive and negative values. So, when x is 0, y would be negative 6 times 0, which is 0. When x is 1, y would be negative 6 times 1, which is negative 6. When x is 2, y would be negative 12. And when x is 3, y would be negative 18. When x is negative 1, y would be negative 6 times negative 1, which is positive 6. And when x is negative 2, y would be negative 6 times negative 2, which is positive 12. So, we'll notice in this case, the y's are decreasing by 6 when the x's increase by 1. So we would say the rate of change is negative 6y's per 1x, or simply negative 6. Finally, number 4. Again, pause the video, see if you can make a table and determine the rate of change. Now, in the past few problems when I've made the table, I've made the x's increase by 1. But if I make the x's increase by 1, my y's will be fractions. And there's nothing really wrong with that exactly, but it might be easier to see the pattern if I make my x's go up by 5. You might be wondering, well, why is it that you're making the x's go up by 5? Well, I know that 2/5 times any multiple of 5 will give me a whole number, which will make my y's whole numbers, which I think it will make it easier to notice patterns. Let's start when x is 0. 2/5 times 0 is 0, and 0 plus 10 is 10. When x is 5, 2/5 times 5 is 2, 2 plus 10 is 12. When x is 10, 2/5 times 10 would be 4, 4 plus 10 is 14. When x is 15, 2/5 times 15 would be 6, 6 plus 10 is 16. When x is negative 5, 2 times negative 5 is negative 2, negative 2 plus 10 is 8. And when x equals negative 10, 2/5 times negative 10 would be negative 4. Negative 4 plus 10 would be 6. Now, if we take a look at our table, we see that the x's are increasing by 2 when the y's increase by 2 when the x's increase by 5. So, the rate of change would be 2y's for every 5 x's, or the rate of change would be 2/5 of a y per x, or 2/5. Now, I hope you've noticed something interesting and significant as we've gone through these 3 problems. which is that the rate of change for each of these equations corresponds to the coefficient of x. For instance, in number 2, the coefficient of x is 1. When we have it's just x, that's really 1 times x, or 1x, and we see that our rate of change is 1. When the equation is y equals negative 6x, the rate of change, negative 6, again corresponds to the coefficient of x, and this even happens when our coefficient is a fraction such as 2/5. This 2/5 is indeed the rate of change.